Hi, this is EGR 305 Advanced CATIA class. Our names are Fran Garriga, Jack Derbyshire, Naara Lozada-Ferreira, and Tanner Heckel. We did the V-22 Osprey assembly.
Alright, so for our final assembly, so we did the V-22 Osprey. This aircraft is used by the military. Also the V-22 has two configurations: the aircraft configuration and helicopter configuration. So for the team dynamic, so Frank focused on the fuselage, Naara interior, Jack landing gear and tail, Tanner wing, engine, and propeller.
This is a final assembly of the interior of the V-22 Osprey sub-assemblies. For the cockpit interior, multiple planes were created in order to make the structure of the interior of the cockpit. In these planes, sketches were created using the GSD workbench. The extrude tool was used to bring the sketches to the proper length, and then the fill tool was used to enclose the extruded structure. After enclosing the extruded structure, the join tool was used to later be able to switch to part design and use the closed surface tool to make the extruded structure a solid. The control panel was made using the same procedure with the addition of padding some sketches and pocketing holes in the surfaces. A multiple extract was done on the contour of the whole cockpit to be able to split the excess. This made the control panel take the form of the cockpit structure. The joystick was made by combining sketches and then using the combine tool. The cockpit seat. The cockpit subassembly included two cockpit seats. A JPG file was uploaded to the sketch tracer workbench. With two sketches in both front view and right side view, the tool combine was used to make the cockpit seat a solid. A hole in the back of the seat and the floor of the cockpit were made to later apply a coincidence constraint and an offset constraint to keep the cockpit seat secure in place. The scaling tool was used to modify the scaling of the seat, since the height provided during the sketch process and the width of the seat were not as accurate to a cockpit seat as they could be. For the fuselage interior, we also did some sketches and then extruded them, used the field tool, and then made them a solid. Same process as the cockpit interior. For the fuselage seat, the sketch tracer was used, and then the combine tool was used to combine these sketch traces. The fuselage seat has a hole in the back also to be able to use a coincidence tool and then the offset constraint to keep them in place.
Alright, so for the tail stabilizer, this is just for the vertical and horizontal tail positions. This was all created using the wireframe design with point analysis and the generative shape design toolbar. You'll see this later attached in the rear aft of the aircraft. For the landing gear, this was all also made in generative shape design for some parts, such as the T-shaped base you'll see in a second on the bottom, as well as the piston rods that extrude the hydraulic. Here it is exploded, so the two black pieces you can see in the picture show the actual rods that stay mounted to the base plate, and the steel and aluminum bars that you can see are a smooth cylinder are actually extruded from the hydraulic positions, and all this was put together into the tires and rims, and you'll see how it all moves on the next slide. So as you can see, as the pressure is put into one, it actually pushes the landing gear down, and when it pulls back, it retracts it from the actual landing base for the V-22 Osprey.
Okay, so for the propulsive assembly, we have the wing, the two engines, and the propellers. This was all created using the GSD and part design workbenches. Here we can see the bearing assembly. It's just a basic ball bearing set that kind of sits in between the propellers and the engines, so there's less friction when it's moving. This is a kinematic representation of the wing, engines, and propellers. Some difficulties building this part were that the sweep of the propellers were very difficult to get. It had to be done using GSD. The profile of the wing was also created using GSD, and it was a big help in making this part. You can see that the propellers are spinning and that they have full range of motion, as well as the engines can turn up and go back down.
Alright, for the fuselage assembly, I use Skate Tracer. So I imported a JPEG into Skate Tracer and then modified to be the length of the actual aircraft that was found online. So I use a lot of generative shape design. In there I use the multi-section tool a lot for the cockpit, the nose cone, and the main fuselage and doors. Also, I use split and extract tools to do the windows and some of the back window as well. Also, for the tail, I use a lot of like a spline tool, so it can modify, it can like adjust that curvature that the actual aircraft has. Also, I use a very cool workbench in generative design called a sticker, so I can put sticker on the aircraft to like actually have the identical sticker that the actual aircraft has. So I also modeled the night vision GPS and refueling system. This was obtained from also a Skate Tracer that I use from online pictures. This is the wing base. I also for this one I use part design. A lot of like sketches and like lines and profile lines were used to model the curvature of the wing base. This is the actual footage of the refueling system kinematics. So now for the conclusion, this project was successful. We did it almost exactly the same as the actual aircraft without using a lot of measurement. They only give us the overall measurement, the length, width, and height of the aircrafts and the wings and tail. So a lot of workbench were used: part design, GSD, agronomics, and DMU kinematics. And yes, our team management was successfully done, but well communicated. We did everything as supposed to be, and yeah, that's the overall project. And thank you for your attention.